So, a brief introduction to what we're going to be doing to complete this abbreviated Geology 492 Field Studies class without a special course fee or the ability to do a lot of travel together. It kind of limits it, but still think we're going to get a good sample of collecting and doing paleo and paleoenvironmental collecting work in the field. So, right off the bat, a little bit of confusion. I had a couple people emailing me and saying, well, are we going both Thursday and Friday? No. Typically, I guess I misrepresented. I kind of put out a couple of days each time before a trip like this, a short quarry trip, and then whatever is the better weather day is the one that's the go. Well, Thursday, there's a good prediction for rain. And the Quarry people, they're a lot stricter than they used to be. For those of you that are veterans of these trips, we used to just sort of drive up and hunker down and get in there. They're a little bit more particular, and one of the things, I guess somebody slipped and hurt themselves. And so any sort of notion of being wet, they're not as inclined to be positive for it. And so Friday's going to be a beautiful, sunny, cool day. So we should enjoy that very much. And so Friday at 10:45, I will be leaving from the parking lot here at Upham. You can either sort of be there and leave with me, or you can just meet us at the location. I'll give you the address in just a little bit in this presentation. And we'll have an 11 a.m. start, and I'll kind of hang down in the quarry there. You don't have to stay the whole time, just kind of stay, linger around. We'll do a few things to learn a few stuff. And then that particular session ends. I'll move back up to the top of the quarry to meet anybody that arrives at the 2 p.m. start. And then I'm going to stay there from 4. So altogether, I'll be there from about 11 till 4. And you should try to make a start or be there right at 11, right at 2. Don't be late and don't come early, because I have to be there to give you your hard hats, your vest, some collecting equipment, and most importantly, we have to sign the individual release forms for each of you and then turn them into the office right before you go down. New rules, folks. Okay, that logistical part is out of the way. Let's look at what we're talking about here. I want to give you a little bit of paleontological background first. In recent years, paleontologists have come up with the notion of the GOBI, which stands for the Great Ordovician Biodiversification Event. It's a time period in the past, the deep past, where life really takes off, and we get a huge increase in the diversity of taxa, the diversity of ecologies, the diversity of morphologies, lots and lots of things. It's actually one of the most interesting adaptive radiations in the history of life on Earth. So it's an interesting thing in a purely biological standpoint, but also in an environmental standpoint, because we want to look at the conditions that made this all possible. So the diagram you're looking at here has time in millions of years ago on the x-axis at the bottom here, and you can see starting from about 484 or 5 million years ago to about 450, and then beyond, you have this sort of rising increase in diversity. That's what we're looking at right here. As we're doing this sort of comes along as what they call a plankton revolution. Plankton being sort of the base of the food chain, which causes an increase in the diversities of the various level bottom communities through here, and then the origination of more modern reefs after that. And so collectively, these three events then sum up to make this Great Ordovician Biodiversification Event. Just another view of it, and again, sort of looking at this middle Ordovician period, as this thing sort of climbs up, that's the Gobi right there. It levels off, and then this is big drop over here at the Ordovician Silurian boundary is the first of the big 5 mass extinction events. So you see that this kind of has this pattern of great increase in life, adaptive radiation, stabilization, and then a mass extinction at the end. Well, from an environmental perspective, we're most interested in this first half, the adaptive radiation part. If we look at a map of the world at that time, so it's sort of in the middle Ordovician, almost 460 million years ago, right about where my cursor is now, that is where Wisconsin was. So a lot of people here have heard me say that Wisconsin was a tropical paradise, south of the equator and under the ocean. There's your evidence. So here's the outline of ancient North America, which then was called Laurentia. You can see the outline of the Great Lakes, and there's Lake Michigan, and so we were under shallow water. That shallow water would have been filled with life forms like this, all kinds of beautiful sea creatures, mostly living on the bottom, benthic style, but some actively swimming over here. The oceans would have been filled with this. In Wisconsin, we are blessed to have some evidence of this Gobi in our rocks here. So this is a stratigraphic column for basically the southern half of Wisconsin. And we've got the Cambrian, Ordovician, and Silurian. And the purple rocks right here are what we call the Sinope group. This is the group that forms the local stratigraphy for us. 2 major formations, the Galena, and then below it, the Platteville. The Galena, I'll point out in the Quarry, is not a particularly good unit to sample for fossils because it is highly dolomitized. The Platteville formation is slightly dolomitized and not even completely throughout the whole formation, which leaves us some opportunities to collect some fossils. So our local evidence of the Gobi is the Platteville, and conveniently, some of the deeper quarries in the area have dug down and reached this middle part of the Platteville formation. If you were to actually see some samples of this, the Platteville, here's just a slab, and you can see various fossils showing out. Most prominently, you can probably see the coiled large snails, but there's also some shelly brachiopods, there's corals, there's all kinds of things. This is the type of stuff that we're going to see, the type of the stuff that we're going to collect. The quarries around here are used for building material, and because of that use for these things, there tend to be a lot of them. This is a project that, she misspelled Ordovician, but a recent graduate did for me. These are the known active quarries that have produced lots of fossils in recent years. And then the red star is the House Brothers Quarry, where we are going to be collecting. And so, of course, the UW-Whitewater campus sort of straddles this sort of Jefferson, Walworth County line over here. Looking a little closer, here is Whitewater. Here is Fort Atkinson, where you have the red oval shape. That is where the quarry is. Now, normally we would just exit out the north side of campus and take N to Cold Spring and then turn on M, and there it is. But there is road construction here now, so we can't use it. So we have to take 12 all the way back to Fort and get on M over here. And so then you get on M and it'd be a left turn. You'll see a sign like this, and this is the address that you need to put into your GPS to get there. W5674 County Road M, Fort Atkinson. When you turn into this little area, you'll see easily my vehicle, but some others perhaps. Right on the left side, there's a little loop, and you can just kind of park your car there. There's a porta potty at the top, and then facing you will be a trailer. And so just sort of get there, park your cars, don't block the loop, just kind of park off to the side, and we'll get in that way. A little bit of explanation as to why this quarry is there, why any of them are there. The Q, the yellow thing here, is the Quaternary Pleistocene sediment overburden. And you can see how the actual hard solid bedrock below has a very uneven surface because of millions of years of erosion, and then probably most importantly, the glacial erosion in the last few thousands of years, sort of plowing out different areas here. And what it's done, it's left certain places where the bedrock is very close to the surface. And these are the places where quarries have been located. The OS symbol, that is for that Sinope group of the Ordovician that we're interested in, the Galena and the Platteville. You see here's the location of Fort Atkinson, here's Jefferson, and so we're kind of in this general vicinity. The Howes Brothers Quarry from satellite view, here is County Road M right there. Fort Atkinson would be off to the left, ultimately Cold Spring and is off to the right, Whitewater off to the right and down. If we sort of look here, then there's the little left turn in here, and you can sort of see the little loop where you would park your car. That's where I'm going to give you your hard hats, your vest, and then get you to sign the release that I'll immediately turn in, and then we'll hike down here. So you see it's a good hike down a hill to reach where we're going to go. Closer view of where we're going to go in 3D view. The upper parts of the rock shown here are the Galena group. Galena Formation, not fossiliferous for us. Where they've gone down much lower is where the Platteville Formation is, and that's what we're going to hit. Here's a view down in the quarry. You can see a bunch of other students on a beautiful sunny day, and we all have hard hats on and colorful vests. It's a requirement for the quarry people. And I've marked off the stratigraphy here, the sort of beige, buff-colored rock at the top. That's the Galena Formation, and where you see the blue down below, and you see where they've dynamited it, they've sort of thrown up all these huge busted-up boulders. This is the Platteville Formation, the Mifflin member, and we'll get to this in just a minute. Before we do, I want to point out that sitting right on top of this, disconformably, are Pleistocene rocks. So these rocks are almost 500 million years old, and then these are between 13 and 15,000 years old, sitting on top. What that is, it is the remnants of glacial Lake Scuppernong. So here are the counties around us. So here's Dane, Jefferson, Dodge, Walworth, and so UW Whitewater would be right about here. And the blue pattern is where this Lake Scuppernong covered the landscape. So we were underneath a large freshwater lake during the Pleistocene at this time. And there's a little bit of samples of it here. We can no longer get up to that in this quarry, but in other places you can. And you all know I love snails. Here's just a sample of glacial Lake Scuppernong. Lots and lots and lots of snails that we've done different things with. And one of the things we've done is sending them off to a lab in Florida that does radiocarbon dating for us. And we took this particular species, bunch of snails. They're little, so you need a whole bunch to get a gram. And for about $600, that's half price. That's for educational institutions like us. It let us know that the lake at this particular place where it was sampled, and this sample comes from Watertown, was at about 13,500 years old, plus or minus 60 years. All right, we're not going to look at that today, but we're going to dive down here to the Platteville Formation, which is about 450 million years old, and just a couple of views of what we're looking at. There's lots of loose rock. Some of these boulders are firmly situated there, some are loose. We have to be very, very careful when we're hiking and walking over this, which again is why we don't want to do this when this is wet in any way, shape, or form. I'm going to ask that everybody be very, very careful doing this. And always be aware of your surroundings. Be aware of who's below you in the pile, who's next to you, where you're stepping. Is that a solid rock mass or not? As far as the actual collecting goes, these are huge blocks of limestone and dolomite, but you can see this block here, these vertical stripes, and over here, those are little muddy shale partings. And so you'll see fossils on the top, and you don't just take your hammer and whack them out. You kind of bust along the edge and stick the pointy edge of your hammer within these little cracks and kind of pry them out. And if you're lucky, you can get some nice prizes like this. I got this one just a few days ago. And you see you've got some snails here. You've got a trilobite. You've got a couple of or several brachiopods, 2 different bryozoan species, a remnant of a large cephalopod, just a lot of possibilities. Depositionally, environmentally, we're looking at what's called a carbonate ramp, just a shallow, continually sloping edge of the ocean basin, and the different rock types that are deposited in these ramps. So in the shallowest areas, you have these pack stones to grain stones and even reefy deposits. These are the high energy rocks. And then in the outer areas, the deeper water, you get wacky stones and mudstones, the more quieter rocks. Now, sea level was bopping up and down throughout this time period, so that you have in one given place at one time there might be high energy rocks deposited. If sea level rose 100 feet, whatever, I mean, we know it rose many times back and forth, then you'd get deposited on it the shallow or the muddy or deeper water deposits on the shallow things. Just some rock types. Some of you are aware of this, some of you are not. We look for carbonate rocks. We examine them with an eye towards the shells within them floating in the muddy matrix. And if you just have a few shells in the mudstone, in the matrix, we call it a mudstone. Add more than 10%, it's a wacky stone. Once they start being so abundant, they're all bunched together. It's called what we call grain support or clast support. That becomes a pack stone, and if we have no mud whatsoever, it's a grain stone. Don't worry about these other 2 terms here. If we go back to this sample right here, I would call this one a pack stone because it's got lots and lots of shells. They are in contact with one another, so they are grain support. But you can see it's still floating in a muddy matrix. And when you're looking at any one of these blocks around here, you're going to see mudstone, wacky stone, pack stone, grain stone, places where it looks like there's just mud and no fossils whatsoever, places where it looks like it's packed with solid fossil material. So you'll see all these different types, just a couple different views of the same thing. Here's grain stone, pack stone, and then the wacky stones, mudstones. So it's be like this, fossils floating in muds. What might we see? Well, here's what I hope we get here, some snails, and this particular one is Lophospira. Just the general environmental information for these things. They're solitary, mobile, benthic, epifaunal grazers. People have done some work in recent years sort of mapping where these things were in the ramp. And you can see here's one of these ramps. So there'd be the shoreline here, and then the distribution of water this way. And Lophospira is generally a shallow water fauna. And here's a different snail, and I took this picture just 3 days ago. This is Sinuides, a very long snail here. And this is another example of a slab I couldn't collect. There's no good place to break this off. If I were to keep hammering around this, I would destroy it, so I just took photographic data. Feel free to whip out your cell phones and take your selfies and post your selfies everywhere or wherever you want to do it, but also take a few pictures of some of the fossils. Some of these things we won't be able to get out, but you'll still be able to see. This particular one we call sinuides, and sinuides, you see, is a fossil that is more distinctive of the deeper water area. So in this same area of busted up blocks, we're going to have evidence of shallow water deposition, deeper water deposition, and it bounced back and forth all around. Other fossils you'll see there, here's a large coral, Favosites. Here are some bryozoans, and if you're aware of these things, what they are, fine. If not, so I know some of you haven't taken Paleo or even Geology 204. Just let me show you. If you find something, I'll kind of identify it, but we'll also have some other veterans on the trip that can help you as well. Crinoids, you'll see some long sort of stemmy pieces like this of sort of little cylinders with little sort of concentric marks, crinoids. Brachiopods, shelly beasts, they look like little clam snails, but they're not. And then a few large evidences of Endoceras, those sort of swimming large nautiloid things that we saw in one of the pictures earlier. Receptaculites is possible. This was a large algal ball. Of course, we also have trilobites, all of these things. And so if we go all the way back, let's go, I'm going to go back to this picture right here. Collectively, all the things in the quarry that we see are reconstructing this environment here. A bunch of small shelly organisms that lived on the bottom, some that swam above, muddy substrate for the thing, and when they died, their skeletons became part of what's preserved for us. Such that what you might find is something like this, another block that I got just from the other day, brachiopods, bryozoans, there's a snail, part of a trilobite, another highly ornamented snail. Here's a coral, a different coral, a little solitary coral, and so we'll find these things out there. Anything you find on these trips, I'm going to let you go ahead and keep it. I'll just take a picture of it. No matter how good it is, I'm going to let you keep it. You're responsible for hauling it out, though. So that's all I ask. And that's a good enough introduction for where we're going to go, what we're going to do.